Today we are going to talk about soft sensors. What a soft sensor is. Soft sensor as a term consists of two words. It's soft and sensor. Soft is from software, so basically it's a computer program. And the second is a sensor. It's like a device that delivers similar information as hardware counterpart. So basically, delivers data. That means a soft sensor is a sensor that is in general as a model that will provide you measurements that you cannot measure directly. And in this case, instead of a hardware sensor, you will apply a soft sensor to get the same or similar data. Let's consider a soft sensor architecture or a structure. So we can think of a process, and from the process we can extract some process variables, some process values. For example, it might be temperature, it might be pressure, for example, it might be viscosity. These process values we can use to build a model. So it might be a first principle model, it might be data-driven model. At the end, we would like to have this model, or in other words, we can name it estimator. Because we would like to estimate the parameter. We cannot measure it, but we can only estimate it based on the parameters we can measure. And then the main advantage of soft sensor, or comparing to a model, soft sensor is some sort of an application of a model. That means soft sensor can deliver results as a normal sensor, and in this case it will deliver results to our process control system. Why do we need that? In this case, we can, for example, control our process using the information from our estimator. And exactly this, the combination of the sensors we already have and the data they provide and our estimator or model is exactly the soft sensor. It's also important to mention that comparing a model and soft sensor has connections to the process. That means it has the process variables, and then it also has connection if it's needed. In most cases it's needed, a connection that through which we can output the estimated value. Whether there is a control loop or there is no control loop, it's not that relevant. For our case, important is this connection. So we get this estimated value back in our process control system. So now let's consider types of soft sensors. Because the soft sensors are based on models, that's why we also have the same types of soft sensors as we had for models. So there are rule-based, that point the process industry, they're so-called first principle models based. And the second type you already know, it's a data-driven or data-based soft sensor, where basically you use a data-driven model to predict another variable that cannot be explicitly measured. Let's consider some applications for soft sensors. So there are three types of applications, general types. First of them, we can predict a certain value. Let's consider this a regression problem, but basically we can predict a certain value based on the other values we can measure. Let's say it's feature 1, feature 2, and for this set of features we can predict our y. Why do we need that? So basically, for example, we can imagine we have some process variables. It's mostly like key indicators, or for example, product quality indicators or process performance that you cannot measure directly. It might be also the, for example, quality of our substance, of our product, that you can measure, but only, for example, in offline manner. You cannot measure it very frequently, although you would like to have it very frequently, for example, for process monitoring and optimization. And it might be very costly to measure certain parameters. And that's why we would like to build a model, and this model can replace your real sensors. So you basically can have some sort of a replacement for your real measurements. Then the second application would be to use the soft sensors to process monitoring and as well as process fault detection. It's more like in the direction of classification tasks. And in this case, the models are mostly based on statistical features, although it might be also machine learning models. But basically, you can define whether your process is going well right now or not. Traditional operator would look at the data, different variables, and make a conclusion whether the process is going well or not. As soon as we have computers and we have models, we can support the operator in this task. We can use soft sensors. We can build the models for this particular purpose and use it, for example, for process monitoring and fault detection. The third application of soft sensors, it's you basically try to understand whether your real sensor is fault. And then if it's fault, you can reconstruct its values by using the parameters from other sensors combined with the model. For example, you can imagine you have a distillation column with maybe 10, 20 temperature sensors or pressure sensors, and one of them doesn't work anymore. In this case, you can remove it. You can first identify that your sensor, for example, returns every time zeros or the minimal value, although the other sensors are returning plausible values. In this case, you can say, I detect this sensor doesn't work, how it should work, and then I can replace it if I have some sort of correlation model where you can, for example, say you have different temperature sensors in your column, and this sensor doesn't work anymore, and you have a temperature profile which normally looks like this. And in case your sensor doesn't work anymore, you can say, I will just use this model, the previous data I collected for this plant, for these operation conditions, and then replace it. But those are three major applications. For sure, there are more specific applications, but those are the types of applications we can talk about. Now let's go about challenges. So what are the challenges we have if we would like to implement to create a soft sensor? First challenge is for sure, if we are talking about data-driven soft sensors, and we are going to talk about mostly data-driven soft sensors further. So the main issue is data. So what does it mean? That means that data might be of a low quality. It might have missing values, data outliers. There might be some features that you might want to exclude. A sampling rate for different parameters might be different. There might be some measurements delay, and so on and so forth. So first of all, what you need to consider if you build a data-driven model or data-driven sensor, soft sensor, you need to pre-process to prepare your data. So basically, to address this challenge, we will talk about data pre-processing. So which techniques will help us to actually make our data better, to make our data suitable for the modeling part. Another challenge we have is our processes. I mean, processes in the chemical industry mostly, they are very dynamic. That means we have dynamic data. And this dynamic is not only about, for example, when you go from one state to another state, but it's also dynamic in the process itself. So every time you repeat the same action, the same recipe, the same state change, you might experience some differences compared to the previous time. It might be some degradation, for example, of measurements of your sensing devices, of your process catalysts, zero drifting. A lot of events can affect this. And in this case, we need also to apply some sort of model monitoring, because in case our model does not correspond to the data, not training data we trained our model on, but real data we're receiving from the plant right now, it might be a problem. So we have this dynamic, we have this degradation, and so on and so forth, also about data. But a more specific challenge, and in this case we need to monitor our model, and we also need to maintenance our model. What does it mean? It means we need to check our model repeatedly, and as soon as we find out that the model doesn't correspond our real data, in this case we might probably need to retrain the model, adjust our model, or do something with our data, for example, calibrate our sensors. The third challenge we will be talking about, it's modeling as I already mentioned, the processes, the phenomena we are describing with models in process industries and chemical industries are very complex, and that means we also need very complex models. So models must be complex enough. Moreover, they might be, or in most cases, they're multidimensional. And they are also highly non-linear. And exactly such types of models we need to create to be able to build a soft sensor that is more or less performant for our processes. And how we can address this challenge, mostly what we also be talking about further, it's deep learning models. Very complex model structures that they're complex to train, to build a model, but at the same time, the expressiveness of these models, the complexity of phenomena the models can describe is very high. And that's exactly what we need. So, as I said, next we will be talking about challenges and also about how we can address the challenges, what are the techniques and methods we can solve the problems arising from the challenge.